think. All right, cool. Then welcome everybody to my talk, Frontend Architecture, in which we learn how to build a zoo. My name is Thomas Gossmann, or Gossi in short. That's what my friends call me. I work for Clark. We take care of your insurance situations, and this is where you can find me online. And let's get started. So first of all, maybe what is software architecture? What was once a role is now turning more into a skill. So it's on us to develop an ability in which we can reason about trade-offs on larger scopes or understanding a design when we're implementing a feature. So instead of having an upfront heavy design work, it's now turning more into a flow of decisions. Or, as my colleague pointed out, software architecture is the stuff that's expensive to change. So we better have it right from the beginning. And we do that today by examining this while building a zoo. Disclaimer, I'm not a domain expert at all. This is all made up by myself. So first part is speaking about the strategic design. But I have a question for you at first. So you open your editor. Maybe first time you enter a code base and you see this. And my question is, do you know what the product is doing? Yeah, okay. Maybe not the best example. I have another one for you. Maybe this helps. Do you know what the product is doing? Maybe also not the best example. I have another one for you. This one. Maybe now? Maybe? Well, I couldn't make sense for any of these. So there must be something better. I want to open up a code base and I will see what it's about to do. So, and the first thing, or the first step we can do is to identify the domain. What is it doing? What is it that people want to go into the zoo? Is it for the animals? Or maybe for the plants, enjoying a nice flora, nice gardens maybe. Or maybe people come for infotainment or entertainment. Or maybe they come for food and drinks, but potentially not for the zoo. And this is all valuable to have in a zoo, but we need to say, okay, one is more important than the other ones. And this is where we can separate or give more reason to the domains here. And having this as a core domain, this is our USP. This is why people come into the zoo. It's all about the animals. Supporting subdomain, it helps the core domain. Nice plans can improve the experience we have while visiting a zoo or reading about and learning about the animals. And then in the generic domain, we have like foods and drinks and restrooms, because that keeps the people in the zoo. Now, this might be identical to your account management because most of your products, you need to have people register and log in later on, but this is not what you make money with then. So, and for today, I want to focus on the core and we'll leave out the other parts. So, I brought a zoo here, and it's actually the zoo in Berlin, which I went to when I was in my teenager years. And the zoo is huge. Like, with an entire day available, we couldn't walk and explore the whole zoo. And maybe that's the same for our code that we write or the products we're building. It's too big to explore this like on one day. You need a little time to onboard, etc. So we need to like slice it down to some manageable pieces. And here's what I did. I put some areas around the zoo. So we have the aviary with the birds. We have the savanna part. Antarctica is, of course, in the middle of the savanna. Then we have some mountains, Asia, Africa, predators, the aquarium, and some Oceania on top here. Okay, so the zoo is a bit like tinier, a bit more manageable. What's next? Now that we have the zoo like cut down a little, we can look into bounded context. And bounded context is one of the models we can have amongst others that coexist in a big project. So for the bounded context itself, they need some explicit boundaries. And within these boundaries, they are strictly consistent. And they also give us clear definitions and communicate the purpose to other people, other stakeholders. And within the boundaries, we have a given autonomy, which is great for teams to work on themselves and not like depending on other people. So as I said, we need to have a skill to see, to do the trade-offs. So here I brought an example. What do we use as a bounded context for the zoo? The first option is we can use the compounds because they have a natural boundary in which they can react to events outside, like visitors, like waving, or maybe the zoo staff gives them food so they can feed the animals. Sometimes happens. But inside, they are pretty much autonomous. Option number 2 is we can separate this by the functional stuff. So the zookeepers, the medical staff, the gardeners, each of these functional teams, like they have their language by the discipline. They might be interested in different information about the animals. A zookeeper, like, are the animals, do they have access to all of the nutritions? For the medical stuff, they want to know if they're healthy. And the gardeners, well, they want to know which plants are in the compound and which perhaps are toxic, so they need to get them out. So this is like by the ubiquitous language of these functional teams. And then option number 3 is we'll go with the areas that I made up before. Here we have perhaps cross-functional teams, zookeepers, medical staff, gardeners, that are responsible for one of the areas here. So, and we arrange the bounded context about the team, about their communication structure, to keep it short, so you don't have to get a long way until they found information what is actually going wrong in one of the compounds. Now, with these 3 options available, I choose for the compounds, because I couldn't ignore the natural boundaries. They have a too good metaphor. So, and also I'm not a domain expert for the zoo, so and I hope this is like a good visual example that we can go by for this talk. And I decided to use these themed areas for our hierarchical organization. So we have Africa, and in Africa we have a couple of compounds. So this is how I sort of sliced it down, or like give it the different zoom levels. So on the highest zoom level, we have the entire zoo. Then we see the mountains in this case, and then we have one compound. And later on, we go into the code. And this is actually based on the C4 model. It's by Simon Brown. It's a way to model your software, to visualize it. And it's sort of a maps of your code. And luckily, I brought one. So it's like Google Maps where you can zoom in, zoom out, and see more of the details or see it from a bird's eye view at glance. But when we look into the vocabulary, when we open like the books, the literature around, then we see all of these names, like context mapping, generic and supporting subdomains, bounded context again, what is distilling? And this is like scary to some people that are first like introduced to these parts. But there's also people that are aware of this. And what you need to do is to understand your partner that you're talking with. Can I use this language or not? And when it's the situation that the other person does not understand it, we perhaps are wise to choose to a different language to make it still understandable to them. So if you're looking at the bird's eye view of your architecture, but then maybe go into a pairing session with your junior engineer that is about to implement a feature, that's perhaps a bit of overwhelming, and then you're wise to have a better or other language. So how we can get there with what we've done so far is we can use our zoom levels and put another layer to it, to another dimension. Here I use the business language, so we can see the entire system as our entire business, the entire zoo. The areas become our business capabilities. The compounds will be our business services, and in the code, this is where we have the business rules that actually operate on this. And also, the C4 model gives us the naming here, which is context, containers, components, and code. So 4 words starting with the C, this is where it gets the name from. When we looked into this in like containers and components, wow, these are overloaded terms. No, this will not work for us. This is like having too much ambiguity. And so you're then good, and a good idea is then to use the language that maps your product. And in this situation, it's this one. The zoo, the themed area, the compound, and later on the code. And everybody from business, engineering, and design will understand it, even though we use some engineering methodology. And now, this is our new zoo folder structure on the highest level. We have the themed areas. They give us like the entrance into each of these worlds. And I think that's a better start if you open up the code and can understand what the business is about. Okay, the result of like going and doing the strategic design is we understand the domain, we distill it down to manageable pieces, we carved out the bounded context, and we established a language that works across disciplines. Pretty good so far. Let's go into the next level, the tactical design, and where we look at level 2 and level 3 and what's happening inside there. So again, if you look up into the literature that tells you what you will find in there, this is the words you get. We have aggregates with all the objects and entities, we have services, we have events, factories, and repositories. And it's like, but I work on the front end. So repositories, that's for backend. We don't need that. Like, okay. Factories, much likely as well. And the other parts, yeah, that's actually, we could work with them. We need to understand how, like, the equivalents on the front end side for that. So let's start with the aggregates. An aggregate is also an object or a thing that has a boundary. In there, we'll find entities and value objects. One of the entities is promoted to be the root entity, and that's our gateway into this. So within this aggregate, we have like system rules and etc. I not focus on this one, but it's also more interested for backend people. And we do have a similar thing on the front end then, which is the projection of this. So a little bit tinier, because backend people usually work with more properties, more information, and then they filter it until it reaches us in the front end. So we have a little bit less information here, but it's enough to convey the message to the users using our product. So this is aggregates. Now let's hop over to services. Service itself is like a very heavy overloaded term as well, with infrastructure services, application services, but what it means here is actually domain service. And that domain service is there to like run the business process. In this case would be feeding an animal, for example. So it performs the task that needs to be done to do that. So in the front end, the equivalent to that is actually that we have a UI to that. We have screens where we can kick off a process. We have forms that actually, where we enter the information. These can appear on screens or maybe are embedded on other screens. And then we have status elements that tell the users of our product how far the process is, what's the next steps, etc. So while we are speaking about UI, let's have a look in here. I think that's a very famous picture, screenshot from Brad Frost and Atomic Design, in which he explains the model, or the methodology. But it has a little problem here, which is the words down here, exactly here. I put your arrows there. And this is the names here that people take for granted. Well, if we remove them, what we see now is, okay, we have a system that has little pieces that compose into larger pieces until we have entire pages. And now that the names are gone, we can use our own names again. And this is where component classification comes in. And here's what I did for the zoo. I said, okay, the pages, they are components responsible for an entire themed area. Could be screens, routes, or page components. And then the templates, let's turn them into pathways that connect the themed areas, that connect the compounds. So it's the walking infrastructure for the visitors of your zoo. And then if we go like into tinier scales, we have the organism that are now our compounds, so one component responsible for one compound. And the molecules, they become the interior of the compounds, like custom tailored elements that is only built for that particular compound. So might be a rocks figure or an aquarium. And you should not move the aquarium into something that requires rocks. So it has a purpose given. But the things that we can move from one compound to another, that become our carnivores. Like little elements, that's fine to have them in every compound. That's good. Now we have used the same methodology, but we applied our own naming again and put it into the domain of a zoo. Also very good again, because in Frontend we like to speak to our designers, and they also get this idea of speaking about the components in this format. Okay, now back to this models. We understood now what aggregates and services are, but actually how do we understand which aggregates and services exist in our domain? And there's a nice methodology here called event storming. It's a collaborative workshop sort of style. We'll go into a room with like a cross-disciplinary team. Might be designers, engineers, PMs, but most importantly, you should have domain experts in there. And what you'll do is you'll have a lot of post-its and then write down and describe your domain. It starts with events, where you have the facts about your system. You write it down, put it on the wall. Next up is the commands that trigger these events, and the read model from which this can be started. Then you place the actors onto the commands, so you know who is responsible for executing it. And then system policy is more like, let's say this goes into the automated processes that we built. So if you do this in a room, then at the end, most of the room is like put up with post-its, and you have a good understanding of actually what's happening. So we can increase our models. The events, I color-coded them a little, and then we have added the commands. And there's another thing that we can use, which is OOUX, or Object-Oriented User Experience. That's a model created by designers. And that's matching more what they do, but is like taking the idea from class diagrams in programming. So this is why when designers use it, they are happy to talk to the engineers, because they have a very much understanding because of the similarities. So in this model, you speak about the object or your class, and then it has two different sets of properties, contents and metadata. Like metadata is here that you can group, filter, or sort your objects, and content is more what you search for them. And then what the fourth element here is the actions. So what you can do with the object, it's the actions that are associated with that. So I made up here an OOUX animal. So we have the animal, it maybe has a name, it has a fur, and then more properties like the family, the genus, and the diet, so what they are actually eating. And then the associated actions would be, well, we can watch the animals doing that, we can feed them, or we can pet them. And now let's bring this together. So we have these elements sitting on the back end, and now let's bring in the front end things as explored, and now we have them side by side. But now, here I've drawn or grouped the things that work together well. So we have the objects on the front end, the aggregates on the back end, and this is nice to have this sort of view to understand the communication between all of the parts. So in the front end, we sit between backend and design, and this gives us the nice understanding on communication paths. Likewise for actions and commands and services and UI. But when it comes to storing this in our code, this is not very helpful. So here's another one. I grouped them a bit different, and the idea is on the larger group is actually our business logic, and down there we have the UI in which we can see that. And that's actually a good thing to do, to separate the UI and the business logic in your code. So the business logic, as mentioned before, it contains your aggregates, the entities, the value object, like your nouns, and the actions, the verbs, what you can do with them, and some policies and rules based on your business. And next to that is the UI, where we have the visual representation of that, in which we can communicate this system state to the users using our product, or offer them some behavior like, hey, do you want to feed the animal now? And this has a lot of benefits, as we learned. So it gives you great maintainability. It significantly improves. It gives us a lot of readability in the code when you look and browse through the code, where you see where you want to make a change, etc. It gives you the feeling of a home. So when you write in your piece of code, you know where it belongs to. And all of that helps to have a fast feature development, and whom you don't want to sell with that. So here's our new folder structure within our themed area. So the savanna is our themed area. The cattles, this is our compound, our bounded context. And within there we have the core, which is our animals. We have, in this case, the bison, the buffalo, and the yak, and the UI next to it. All right. So what's the result of this? Front-end modeling is actually sitting between backend and design and bridges this together. Separating the business logic and UI is great to have this in maintainable and manageable form. And again, we used a language for our component classification that matches with the product that we're building in our domain. Which brings us now to the last part, going into the code. So let's start with the aggregates here. This is ideally written in plain JavaScript or TypeScript to have it framework agnostic. And then in the second step, we can connect this to our reactivity system, because whenever we want to make a change there, we want to see this reflected in the UI, and we don't want to work on the logic that does it. And there's two things where we can see that. One is classes to do that, where we need to think about or take care of serialization, hydration, and initial state management. And on the other side, we have the function part where we describe the shape of our objects, and then we have to deal with transforms. Now, classes are here because when you look up the books, they usually use an object-oriented language like C# or Java to explain this, but it also works fantastically well with functional programming. So what's your choice is depending on which reactivity library you're using, what your framework offers, etc. So what you can better reason about this perhaps then. And a hybrid of this works as well. Next up is which I found a very much underrated design pattern. It's the command and queries separation. And the idea of this is that we write functions or methods, and that they perform an action to cause side effects, or they retrieve some data, but never do this at the same time. So let's start with queries. They are like questions, like asking facts about our system, or abilities or authorization that help us to control the access. And the next one is actions and commands. So it follows the command design pattern. And I think we have some lingo shift here, perhaps. Commands are more used on the back end, and in the front end we use actions. And an action call triggers a command on the back end, but action helps us actually to communicate better with our designers. So let's see how they do and work. Queries here, or questions, is we might want to ask, hey, is this animal an herbivore or carnivore? We can answer this by looking at what they eat. And then we can use this information, this fact that we now know about the system, to control the access. Hey, can we pet the animal? Maybe, if this is not a carnivore, because maybe then the animal tries to eat you. So going, yeah. And even though you see that it's a one-line function, but you can expect to have hundreds of them. And it's fine. That's the expected case. You see all of the questions, you see all of the controls and the abilities, etc. So queries, here we can control or use them to control the access. Can we watch the animals? We return true by default, but we now have a control in place, so whenever the compound is under construction, we can return false, and no visitor is able to walk there, for example, because we closed the path. Can we feed the animals? Maybe we shouldn't allow this to all of the visitors, but we keep this restricted to the zookeepers. So this is another example then. So what you should not do with queries is inline them in your code or in your templates, but instead extract them into a function. Because the function is unit testable, in the template you need to test the entire template. So it's more like integration perhaps. And then let's go over to the actions. So they actually cause the side effects. They manage to change the system and invoking commands on the backend. For example, here when we want to pet the animal, we dispatch a post request to the backend with the animal we have given and ask it to pet. Cool. So now we build up an inventory of questions, of abilities, of actions, and we can use them now to connect this to our UI. So you don't need to understand the entire code, but on the top part is where we import the actions and the ability. Then in the middle section, we connect them with the UI system of the framework, and then in the part at the bottom is where we use this in our template. So we also connect this with our framework and make use of the reactivity system that this will give us. And same way here is a state chart. So it's to control, to model the mood of a monkey here. So there are the states at the top, but I want you to draw your focus down to the bottom, where we also have actions and guards, which are the abilities and the actions that we've written before. Now here we take the context of a state chart to instruct the, to pass along the elements that we need from the registry or the container. So, and now we connected it to a state chart, which of course gives us deterministic behavior in our application. Now we have a pure core. We have extracted the core into plain JavaScript TypeScript. We have the aggregates, entities, value objects. Everything makes up the aggregates. We have actions, abilities, a nice inventory that we can now throw at our UIs or at state charts, for example. Since this is all framework agnostic, and we can control our entire application through this, let's say, code folder or code package, wherever you want to store it. And it's so satisfying to receive or review a PR that changes the behavior of your application or your UI, but never touches the UI code. And since this is the core of the business, we want to have this highly testable, highly test covered, and we want to have excellent tests around this. So you can aim for 100% here. And another thing is that we can use folders as a signpost to help engineers find their way through the code. So I have an example for this for you here. Well, 3 examples actually. On the left-hand side is we have the monkey house here. In the core, we have the aggregates and the logic separated by this. And then you find this for the gibbon, the aggregate or the logic, which contains questions and actions, etc., or the gibbon mood, which contains a state chart. In the middle is where everything is homed under the gibbon folder. So you'll find everything that is responsible around the gibbon in this folder. Or on the right-hand side is similar to the first one, but a bit more verbose. So depending on how large your model is, and where you have lots of entities or lots of value objects, this can help your engineers to find the right home to them. Because sometimes it's not the best idea to understand this from the naming you give in your files. So this files and folder structure gives a nice home, and choose whatever fits you. All right, the result of this third part is now that we have a core layer in plain JavaScript or TypeScript. We have our business logic covered with unit testing. We can connect them to wherever we want, to our reactivity system, to UI, to machines, etc. We learned to use the CQS design pattern. I think it's too underrated, but it fits nicely with the domain. And we can use folders as a signpost. And the summary of this all is whatever methodology you're given is try to understand the essence, apply it to your system, use it with your product, and by that establish a naming that fits your product, that fits your domain, in which it allows you to speak with all disciplines. And finally, when it comes to the engineering, you can let the code speak your product. So you remember the first screenshots I showed you about where I asked you the folders and what they let you know about the product. So with this all applied, this is what it would look now. On the first level, we see the zoo and all of the themed areas. We know what's there. We can zoom in. We see, OK, in Africa, we have all of these compounds here. And if we look into the monkey house, of course, we have the core and the UI. And this is actually where the folder naming gets more technical. Until then, nothing technical, only about the domain. And that's it. Thank you so much. So.
Thank you so much. This was such a sympathetic thing. And yeah, do you have questions, guys?
Yeah, so my question would be, is there a possibility to go back like 2 slides or 1 slide? Yeah, actually to that one.
Okay.
I mean, generally I like the idea of, that whole thought, but just to give an example, what would you do if there were something like a weather utility library, that is applicable for Africa, Antarctica, aquarium in Asia? It's something above that. Mm-hmm. How would you sketch that out? Does that completely change the logic, or is that you have a recommendation for some sort of utility things that are above everything? Yeah,
actually, let me zoom up here. This is where it actually would fit. So far we focus on the core domain, which is about the business and the core of it. Or what you were speaking about would be more perhaps then in the supporting or in the generic subdomain. Yeah. So there's a place for that as well. More questions? Or is there something online?
No, there's nothing online.
I mean, you can still find me for a little while until I need to drive back. So we'll be shortly well, but still you can reach out to me. You can still reach out to me on Twitter or etc. And I will also make the slides available afterwards. Does it answer your question? Then go ahead, please.
It's connecting to the question that was asked earlier. If you're supporting a generic, how are they incorporated to the folder structure?
In this case, I use the folder structure, but you might also be using packages to have this available on your private registry or so. I thought for the talk, folders are okay, but even though for what we're doing, we have a lot of packages. Okay. So and then you find a scheme that fits you, and maybe a naming hint that tells you, hey, this is maybe part of the supporting domain or part of the core domain, and then based on name you can make a sense of it.
Okay, thank you.
Thank you for your question. Anyone? No? Okay. Thank you as well, online.
Then, thank you very much again, I would say.